My name is Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. This podcast is separate from my teaching and research roles at Stanford. Today, we're talking all about emotions. Emotions are central to our entire experience of life. Whether or not we're happy or sad or depressed or angry is our life experience. And yet, I think with all the importance that we've placed on emotions, very few people actually understand how emotions arise in our brain and body. And I mention brain and body because, as you'll see today, emotions really capture the brain-body relationship. We cannot say that emotions arise just from what happens in our head. The other thing about emotions is that there's no real agreement as to what's a good emotion or a bad emotion. Today, we're going to talk about the biology of the chemicals and pathways that give rise to emotions in the context of food and nutrition. When we see something or we smell something or we taste something that we like, there does tend to be a postural leaning in. We tend to inhale air at that time. We tend to bring in more of whatever chemical substance is there. So we tend to do these and kind of lean in closer to things that are attractive to us. And when we see and experience things that we don't like, sometimes it's a mild aversion. We just kind of lean back or look away. Other times, it's an intense aversion of disgust, and we tend to cringe our face. We tend to avoid inhaling any of the chemicals. This probably has roots in ancient biological mechanisms that are to prevent us from ingesting things that are bad for us, chemical compounds and tastes that might be poisonous. So much of the foundation of any discussion about emotion has to center around this kind of push-pull of attraction to things or aversion from things. Now, that's a very basic way of thinking about emotions. But if you think about it, it works for a lot of different circumstances. And in the brain, everywhere from the deep circuits of the brain to the more kind of what we call higher order evolved centers of the brain, we have this push-pull thing. But at the core of that, of attraction or aversion, is an important theme that you might realize already, but most people tend to overlook, which is that there's an action there. You're either moving forward or you're moving away from something. The brain has a body so that the organism can move. And the body has a brain so that the organism, you, can move toward or away from things that you deem to be good or bad for you. So there are circuits in the brain for aversion and for attraction toward things, and the body is governing a lot of that. And so immediately in this conversation, I want to raise an important point, which is about a nerve pathway that many, many people have heard of, that gets discussed all the time, and that is one of the most kind of oversold for the wrong reasons and undersold, unfortunately, for its real power, which is the vagus nerve. So the vagus nerve is one, not the only, but one way in which our brain and body are connected and regulates our emotional states. The vagus nerve is also analyzing many features within the body and informing the brain of how to feel about that and what to do. So a really good example that I think is an exciting one is as it relates to sugar. So we all know that sweet things generally taste good. So that makes sense, right? You eat something, it tastes sweet, you want more of it. Well, it turns out that it's much more interesting than that. When you eat something sweet, within your stomach, you have cells, neurons, that sense the presence of sugary foods independent of their taste and signal to the brain. So those sensors, those neurons, send information up the vagus to your brain, goes through a series of stations, and then you release dopamine, this molecule that makes you want more of whatever it is that you just ingested. In fact, this pathway is so powerful that they've done experiments where they completely numb all the taste and feeling in somebody's mouth. And what it tells us is that we have circuits in our body that are driving us towards certain behaviors and making us feel good, even though we can't perceive them. Now, for those of you that are really interested in gut intuition and kind of gut feelings, this is a gut feeling, except this is a chemical gut feeling. This is a particular set of neurons detecting that something in your body has a particular feature, in this case, the presence of sugars, and sending information to the brain to essentially to control your behavior. And I find this remarkable. I mean, this should completely reframe the way that we think about the sort of so-called hidden sugars in foods. What this means is that even if a food is very savory, like a piece of pizza or a piece of bread or even like a salad dressing, if there's sugar snuck into that and you can't taste it, you will still crave more of that thing without knowing that you crave it because it has sugar. A lot of how we feel while we eat and after we eat is because of this vagus sensing of what's in our gut. It's sending information all the time. Is there sugar? Are there fats? Are there contaminants? There are a lot of information, these so-called parallel pathways that are going up into our brain that regulate whether or not we want to eat more of something or not. And there are accelerators, things that make us want to eat more, like sugar and fats, because those are nutrient dense and they help generally, at least in the short term, support the survival of animals, but also amino acids. And this is very important. There are a lot of data, but much of what comes from the data on what people eat and how much they eat is from a subconscious detection of how many amino acids and what the array, meaning the constellation of amino acids, is in a given food. And it's fair to say that the sum total of these studies point in a direction where people will basically eat not until their stomach is full, but until the brain perceives that they have adequate intake of amino acids. Amino acids, of course, are important because they are the building blocks of, sure, muscle and the other things in our body that need repair. But what most people don't realize is that amino acids are what the neurochemicals in the brain are made from. Now, this is vitally important, okay? So we've heard dopamine is this molecule that makes you feel good. Dopamine release is caused by surprise, excitement, events that you're looking forward to and that turn out well. It is inhibited by events you're looking forward to that don't work out. It's called reward prediction error. Your expectation of something releases dopamine, and the actual event releases dopamine. And if the event-related dopamine does not exceed the expectation, or at least match it, there's a much higher tendency that you won't pursue that thing again. Dopamine is what's going to lead us to want to eat more of something or to not want more of something, because dopamine really is about craving. It's about motivation and it's about desire. And as I mentioned, these amino acid sensors in our gut are detecting how many amino acids, but they're also detecting which amino acid. Let's just kind of take stock of where we're at. We have a brain-body connection. There are many of them, but one of the main ones is the vagus nerve. The vagus collects information about a lot of things, breathing, heart rate, stuff that's happening in the gut, etc. And gut, by the way, includes the stomach and the intestines, sends that information up to the brain. The brain is using that information to decide one of two things: move towards something or move away. Can also pause, but essentially pausing is not moving toward. But foods that give us a big pulse of dopamine will make us crave more of that food. It will make us crave more of the activity that led to the ingestion of that food. And as I mentioned earlier, a lot of that is happening at a subconscious level that you're not even aware of. So the other neuromodulator that's really interesting in the context of the vagus is serotonin. Serotonin, just to remind you, is a neuromodulator. Therefore, it creates a bias in which neural circuits, which neurons in the brain and body are going to be active, and it makes it less likely that other ones are going to be active. And serotonin, when it's elevated, tends to make us feel really comfortable and kind of blissed out wherever we are. And that contrasts with dopamine and epinephrine, which mainly put us in pursuit of things. Motivation is pursuit. First of all, some of you, but perhaps not all, have heard that more than 90% of the serotonin that we make is in our gut. And indeed, we have a lot of serotonin in our gut. But here's the deal. Most of the serotonin that impacts our mood and our mental state is not in our gut. Many people adjust their serotonin by just eating more food. And carbohydrate-rich foods will increase serotonin. I eat a relatively high protein and moderate fat, zero carb or low carb meal at lunch and in the afternoon to stay alert, because those foods tend to favor dopamine production, acetylcholine production, epinephrine production, and alertness. My mood is generally pretty good most of the time. And then as evening comes around and I'm concerned about sleep and a good night's sleep, not concerned in an anxious way, but I want to get a good night's sleep, I will ingest foods that promote serotonin release because they contain a lot of tryptophan. So as you're seeing, this isn't really a discussion about nutrition per se. This is a discussion about food, which contains amino acids being the precursors to neuromodulators, and neuromodulators having a profound effect on your overall state of alertness or calmness, happiness, sadness, and well-being. So now you understand the relationship, I hope, between foods and dopamine, foods and serotonin, and that they're both being communicated to the brain via the vagus, right? So let's talk a little bit more about things that we ingest in our body and then allow our body to inform our brain to shift our mood. But I don't think most people know this simple fact, which is that the omega-3 to omega-6 fatty acid ratio has a profound effect on depression. And they did a comparison of 1,000 milligrams a day of EPA. So EPA is one of the elements that contains high levels of omega-3s that's in things like fish oil, but it wasn't 1,000 milligrams of fish oil. It was 1,000 milligrams of EPA. Compared that to 20 milligrams of fluoxetine, which is Prozac, they found that they were equally effective in reducing depressive symptoms. And what was really interesting, in addition to that, is that the combination of 1,000 milligrams of EPA and fluoxetine had a synergistic effect in lowering depressive symptoms. And now there are lots of studies. If you go into PubMed and you were to put EPA or fish oil and depression, you would find that there were a number of really impressive results showing that it's at least as effective as certain SSRIs, antidepressants, at these dosages. And it can amplify or improve the effect of low dosages of some of these SSRIs. You can discuss it with your doctor and family and make the choices that are right for you. Now, of course, I really want to emphasize something, which is that no one compound or nutrient or supplement or drug or behavior, for that matter, is going to be the be-all, end-all of shifting out of depression or improving one's mood or improving sleep. You cannot expect to take a compound, regardless of source or potency, and have it completely shift your experience of life without having to continue to engage in the proper behaviors, all the things we know: proper sleep, exercise, social connection, food, etc. Okay, so now let's turn to another aspect of the gut-brain relationship that will surprise you, in some cases might shock you, and that has some really cool and actionable biology. And that's the gut microbiome, probiotics, and prebiotics. It is true that we have a lot of these little microorganisms living in our gut. They're not there because they want to help us. They don't have brains. They are adaptive, however. They try and find and create environments that make it easier for them to proliferate. So they don't care about you and me, but they are perfectly willing to exploit you and me in order to make more of themselves. So we are one long tube for digestion. And inside of that tube is a mucosal lining. And the conditions of that mucosal lining set a number of different things. It sets the rate of our digestion and the quality of our digestion. It sets, for instance, our immune system. We're ingesting things all the time. Think about air, bacteria, viruses. They're making their way into our gut. And some of those bacteria live in the gut. And some of those bacteria bias the mucosal lining in the gut, stomach and intestines, to be more acidic or more basic so that they can make more of themselves. Now, some of those mucosal linings that they promote make us feel better. They make us feel more alert. They bolster our immune system, and others make us feel worse. So first rule, the microbiome isn't good or bad. Some of these little bugs that live in us do bad things to us. They make us feel worse. They lower our immunity. They affect us in negative ways. Some of them make us feel better. And they do that mainly by changing the conditions of our gut environment. In addition to that, they do impact the neurotransmitters and the neurons that live in the gut and that signal up to the brain to impact things like dopamine and serotonin that we've been talking about previously. So there's a vast world now devoted to trying to understand what sources of food, what kinds of foods are good or not good for the gut microbiome. Here's a few things that I think you might find surprising. First of all, supporting a healthy gut microbiome is good for mood, great for digestion, and great for immune system function. However, that does not mean maxing out or taking the most probiotic and prebiotic that you can possibly manage. As I mentioned many times before, I do believe in probiotics. I take probiotics, but there are studies that show that if you take lots and lots of certain probiotics like lactobacillus and you really ramp up the levels more, it is not a case of more is better. There are things like brain fog that can come from that. Brain fog is just this inability to focus. People feel really not well generally. The ingestion of fermented foods is one of the best ways to support healthy levels of gut microbiota without exceeding the threshold that would cause things like brain fog. So much so that some people report that when they start eating small bits, because it doesn't require a lot of fermented foods, that their overall mood is better, not unlike the effects of EPA, although I don't think it's been looked at directly in the context of clinical depression yet. There are some things that you can do to really damage your gut microbiome. And this is where there's a huge misconception that I want to clear up. There was a study that showed that artificial sweeteners, but a particular artificial sweetener, which was saccharin, can disrupt the gut microbiome in ways that is detrimental to a number of different health markers, increasing inflammatory cytokines and all the other bad things that happen when the gut microbiome is thrown off kilter. Saccharin is not the most typical artificial sweetener that's used. The most typical artificial sweeteners that are used are things like aspartame, so-called NutraSweet, or sucralose, or these days stevia. To my knowledge, the negative effects of these artificial sweeteners on the gut microbiome were restricted to saccharin. So what happens is certain artificial sweeteners, in particular saccharin, disrupt the microbiome and make the environment within the gut, that mucosal lining, more favorable to bacteria microbiota that are not good for the organism. Okay, this is an important distinction. It's not just that a language thing where people say, oh, it kills the microbiome. It doesn't kill the microbiome. It shifts the microbiome. And shifts in the microbiome can be good or they can be bad. And that takes us to another topic. That's a bit of a hot button topic, but I'm willing to go there because I think it deserves conversation, which is nowadays there are many examples out there where people have switched from a kind of standard diet or even a vegetarian diet or vegan diet to a keto diet. Now, keto doesn't necessarily have to mean the ingestion of meats, but it can. And they experience positive effects for themselves. But the ketogenic diet is interesting because when one shifts to the ketogenic diet, there is a shift in the gut microbiome, and some people end up feeling better. Some people end up feeling worse. Likewise, some people go from ingesting animal products, including meat, or they're vegetarian and they go to vegan, and they experience positive shifts in mood and affect. So the point of all this is that when I say you have to find what's right for you, that's not a throwaway statement. Some people's microbiome and the mucosal lining of their throat, of their gut, of their nose, everything is improved by diets that are heavily meat-based and don't have many plants. Other people do much better on a plant-based diet without many meat products or animal products. It's highly individual. And this probably has roots in genetic makeup. This probably has roots in what people were raised on. Because remember, the nervous system, of course, is set up by your genes, your genetic program, but your nervous system, it adapts early in life to your conditions. That's what it's for. The reason you have a nervous system is to move your body appropriately towards things that are good for you and away from things that are not. But also, it was designed to adapt so that, yes, indeed, some people may like certain foods and react to certain foods better than others because of the way that their nervous system was wired, this enteric, as it's called, nervous system that lines the gut and that communicates with the brain. So most of what I've talked about today is kind of black and white. These are things that are present in all of us, the sugar sensing neurons of the gut, the way the vagus is wired, the fact that omega-3, omega-6s tend to improve, the ratios tend to impact mood, with high omega-3, omega-6 ratios improving mood. We talked about all sorts of things in the gut-brain and body-brain axis. But when it comes to the microbiome, the key thing is that we all have a microbiome. You want a microbiome, but You want to promote the microbiome that is right for you. And that can be shifted and steered by ingesting certain categories of foods and not others. It's very clear that these fermented foods support the microbiome, that we should be ingesting at least 2 servings per day, which is quite a lot. That supplementation at low levels can be good. Supplementation at high levels can create this brain fog. Even though some people say that result is controversial, I've experienced this myself, and the data look to me pretty darn solid. So that's one thing to think about as well. And the other thing about the gut microbiome is that it's highly contextual based on other things that you're doing. So even things like exercise and social well-being and connection, those things are also impacting the gut microbiome. So find the diet that's right for you and that works for you in the context of the other ethical and lifestyle choices that are important to you. That's my advice. So as we round up, I want to share some results with you that without question will impact the way that you respond to food mentally and even physically. I have a colleague at Stanford, Aaliyah Crum, who's done some remarkable experiments on mindset. 2 that are particularly interesting to me, I want to share with you now because they really emphasize how our beliefs can really impact the way that our brain and body work together. I think the most famous of these is an experiment they did where they had 2 groups of individuals. They were each given a milkshake, and they had some factors measured from their blood by an IV while they ingested the milkshake and then afterwards as well. And one of the factors that they were looking at was something called ghrelin. Ghrelin is a peptide that increases with hunger. So the longer you haven't eaten, the ghrelin goes up. One group got a shake that they were told was a low-calorie, healthy shake. The other group got a milkshake that they were told was the very decadent high-calorie shake. And what they found was that the high-calorie shake had a much more robust effect on blunting ghrelin and reducing ghrelin. But the interesting thing, you probably guessed already, is that it was the exact same shake given to both groups. And this speaks to the so-called top-down mechanisms or modulation of our physiology. In a previous episode about pain, we talked about the effects of, obsessive infatuation and love on pain responses and pain thresholds. This is yet another example where beliefs or subjective feelings can impact physiology at the level of the periphery, because ghrelin is released in the periphery in the body. And so this is not just the placebo effect. This is an incredible set of findings that illustrate the extent to which whether or not we believe a food is going to be good for us or not good for us, these belief effects are not about lying to yourself. So in order for them to work, you have to be naive to the information, right? You can't simply lie to yourself and tell yourself what you want to believe. And that's important, but also important is that the mind and the body are in this fascinating interplay. And today we've talked mainly about how the body and things that we put inside this tube, this that runs from our mouth to the other end, to our rectum, basically is impacting all these cells, these neurons, microbiota in there, mucosal lining, heart, lungs, and how all that information is feeding up to the brain to impact how we feel up here. But also how we feel up here is impacting how our body reacts at levels of very core physiology that you couldn't just tell yourself that this was going to work, but what you believe about certain substances, certain foods, certain nutrients does have a profound effect on the magnitude of their impact and sometimes even the quality and direction of that impact. So today's episode, we took a full journey into the brain-body relationship and discussed a lot of the mechanisms and the actionable items that you can approach if you want to explore this aspect of your biology and psychology further.